Hello students, this is 78th lecture for TY BCom students. Name of the subject is Business Statistics second paper. Second term, Unit 6, Lecture 10. Name of the topic is Test of Hypothesis. First part, testing equality of two population means small sample test. We are going to see t-test in this particular chapter. Small sample test. Second test, testing equality of two population means H0 in notation can be written as mu1 is equal to mu2 against H1, mu1 not equal to mu2. Under H0, the test statistic is given by T is equal to x bar minus y bar divided by S into under root 1 upon n1 plus 1 upon n2. This follows T distribution with n1 plus n2 minus 2 degrees of freedom, where smallest square can be calculated as n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. See the example based on this test. You are given the following data about the life of two brands of bulbs. So brand A, brand B, mean life, standard deviation and sample sizes are given. Brand A, mean life is 2000 hours, standard deviation is 250 hours and sample size is 12. Brand B, mean life is 2230 hours, standard deviation 300 hours, sample size is 15. So do you think there is significant difference in the average life of two brands of bulbs? So we'll start with the null hypothesis. H0 mu1 is equal to mu2 against H1 mu1 not equal to mu2. H0 in words can be written as there is no significant difference in the average life of two brands of bulbs. So under H0, the test statistic is given by T is equal to x bar minus y bar upon S into under root 1 upon n1 plus 1 upon n2. So first of all, we will calculate smallest square as n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2, which is equal to 12 into 250 square plus 15 into 300 square upon 12 plus 15 minus 2. If you perform these calculations, the answer is 84,000. We want the value of S. So we will take the square root of 84,000, which is equal to 289.8275. So after replacing all the values in test statistic T can be calculated as 2000 minus 2230 divided by 289.8275 into under root 1 upon 12 plus 1 upon 15, which is equal to minus 230 divided by 289.8275 into 0.387298. So after calculations, we are getting the value as minus 230 divided by 112.2497. And the final answer of T is nothing but minus 2.04900. So mod T calculated can be written as mod of minus 2.04900. So answer becomes 2.04900 and table value of T for 25 degrees of freedom and 5% level of significance is 2.060. So we can say mod T calculated is less than T tabulated. Therefore we accept H0 at 5% level of significance. So conclusion, there is no significant difference in the average life of two brands of bulbs. See the next example. A random sample of 20 daily workers of state A are found to have average weekly earnings of rupees 44 with sample variance 900. Another sample of 20 daily workers from state B were found to earn as an average rupees 30 per week with sample variance 400. Is there any significant difference between the average weekly earnings of two states? So H0 in notation can be written as mu1 is equal to mu2 against H1 mu1 not equal to mu2. So H0 in words, there is no significant difference between the average weekly earnings of two states. So under H0, the test statistic is given by T is equal to x1 bar minus x2 bar upon square under S into under root 1 upon n1 plus 1 upon n2. So we will calculate smallest square as n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. which is equal to 20 into 900 plus 20 into 400 divided by 20 plus 20 minus 2. So the answer is 684.2105. We want the value of S. So S is equal to under root of 684.2105, which is equal to 26.1574. T can be calculated as 44 minus 30 divided by 26.1574 into under root 1 upon 20 plus 1 upon 20. So the answer is 4 upon 26.1574 into 0.31622. So the final answer can be calculated as T is equal to 4 upon 8.271696, which is equal to 0.4835. So mod T calculated can be written as 0.4835, which is equal to 0.4835. So T for 38 degrees of freedom and 5% level of significance, the table value is 2.038. So mod T calculated is less than T tabulated. Therefore, we accept H naught at 5% level of significance. Conclusion: there is no significant difference in the average weekly earnings of two states. See the next example. Two salesmen A and B are working in a certain district. From the sample survey conducted by the head office, the following results were obtained. State whether there is any significant difference in the average sales between the two salesmen. They have given us the data as salesman A, salesman B, number of sales 20 and 18. Average sales for salesman A is 170. Average sales for salesman B is equal to 205. Standard deviation of sales for salesman A is 20 and standard deviation of sales for salesman B is 25. So H naught in notation can be written as mu1 is equal to mu2 against H1, mu1 not equal to mu2. H naught in words, there is no significant difference between the average sales of two salesmen. So under H naught, the test statistic is given by T is equal to x bar minus y bar upon S into under root 1 upon n1 plus 1 upon n2, which is equal to 170 minus 205 divided by S into under root 1 upon 20 plus 1 upon 25. Let us calculate the value of S square as n1 S1 square plus n2 S2 square upon n1 plus n2 minus 2, which is equal to 20 into 20 square plus 18 into 25 square upon 20 plus 18 minus 2. The calculations are 19250 divided by 36. So the final answer is 534.7222. So value of S is square root of this value, which is equal to 23.1240. So T can be calculated as 170 minus 205 divided by 23.1240 into under root 1 upon 20 plus 1 upon 25, which is equal to minus 35 upon 23.1240 into square root of 0.05 plus 0.04. So the answer is minus 35 divided by 23.1240 into 0.3. So the answer is minus 5.04526. So mod T calculated can be written as mod of minus 5.04526 is equal to positive 5.04526, and T calculated for 43 degrees of freedom and 5% level of significance, we can take the large sample test value as 1.96. So mod T calculated is greater than T tabulated. Therefore, we reject H naught at 5% level of significance. So conclusion, there is a significant difference in the average sales of two salesmen. See the next example. Samples of two types of tube lights were tested for length of life and following data were obtained. Type 1, type 2. Sample size, type 1 there are 8 tube lights, for type 2 there are 7 tube lights. Sample mean for type 1 is 1234 hours. For type 2, sample mean is 1036 hours. Sample standard deviation for type 1 is 36 hours. Sample standard deviation for type 2 is 40 hours. Is there any significant difference in the average life of two types of tube lights? So H0 in notation can be written as mu1 is equal to mu2 against H1 mu1 not equal to mu2. H0 in words can be given as there is no significant difference in the average life of two types of tube lights. So under H0 the test statistic is given by T is equal to x bar minus y bar upon s into under root 1 upon n1 plus 1 upon n2. First of all we have to find small s square as n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. Replace all the values, we will get this is equal to 8 into 36 square plus 7 into 40 square upon 8 plus 7 minus 2, which is equal to 1659.076923. We want the value of s, so we will take the square root of 1659.076923. The value is 40.73176. So T can be calculated as x bar minus y bar upon s into under root 1 upon n1 plus 1 upon n2, which is equal to 1234 minus 1036 divided by 40.73176 into a square root of 1 upon 8 plus 1 upon 7, which is equal to 198 upon 40.73176 into 0.517549. So the answer is 198 upon 21.080688. So the final answer is 9.3924. So mod T calculated is equal to 9.3924 and table value of T for 13 degrees of freedom and 5% level of significance is 2.160. So mod T calculated is greater than T tabulated. Therefore, we reject H0 at 5% level of significance. Conclusion: there is significant difference in the average life of two types of tube lights. See the next example. Good website design make web navigation easier. A sample of 10 users using a conventional web design averaged 32.3 items identified with a standard deviation of 8.56. A sample of 10 users, a new structured web design averaged 44.1 items identified with a standard deviation of 10.09. Test whether the mean number of items identified is equal with both the designs use 5% level of significance. So H0 in notation can be written as mu1 is equal to mu2 against H1 mu1 not equal to mu2. H0 in words, mean number of items identified by both designs are equal. Under H0, the test statistic is given by T is equal to x1 bar minus x2 bar upon square root s into under root 1 upon n1 plus 1 upon n2. Small s square can be calculated as n1 s1 square plus n2 s2 square upon n1 plus n2 minus 2. The value becomes 10 into 8.56 square plus 10 into 10.09 square upon 10 plus 10 minus 2. So the answer is 97.26761111. So S is nothing but square root of 97.26761111. So answer is 9.8624. So value of T is equal to 32.3 minus 44.1 divided by 9.8624 into square root of 1 upon 10 plus 1 upon 10. So answer is minus 11.8 divided by 9.8624 into 0.44721. So the answer is minus 2.6753. So mod T calculated can be written as mod minus 2.6753 is equal to 2.6753 and table value of T for 18 degrees of freedom and 5% level of significance is 2.101. So mod T calculated is greater than T tabulated. Therefore, we reject H0 at 5% level. Conclusion: both designs are not equally efficient. Next example. A filling machine is supposed to fill on an average 100 grams of baking powder in packets to test whether machine is working properly. 8 packets are selected randomly and weighed. Weights were as follows: 102, 101, 98, 95, 103, 99, 104, 102. Is the machine working properly? Use 1% level of significance. So there are 8 packets. So naturally it's a small sample test. So H naught can be stated as mu is equal to mu naught against H1 mu not equal to mu naught. H naught in words we will write as a filling machine may fill 100 grams of baking powder. Now under H naught the test statistic is given by T is equal to x bar minus mu naught upon S upon root n. So for this we need two columns xi and xi square. We will write xi values in xi column, that is 102, 101, 98, 95, 103, 99, 104, 102, and the total of all these values are 804. We will take the square of every observation and we will write the values in xi square column, and the total of xi column is 80864. So x bar is calculated as summation xi upon n, which is equal to 104 upon 8, which is equal to 100.5. Small s square is equal to summation xi square minus n into x bar square upon n minus 1, which can be written as 80864 minus 8 into 100.5 square upon 7. So the value becomes 62 upon 7. So answer is 8.857142. We need the square root of s square. So s is equal to square root of 8.857142. So the final answer is 2.976095. We will replace all the values in the formula. T is equal to x bar minus mu naught upon s upon root n, which is equal to 100.5 minus 100 upon 2.976095 upon square root of 10. So the answer becomes 0.5 upon 0.941123. So the final answer is 0.531279. So mod T calculated is mod of 0.531279 is equal to 0.531279. Then this is the calculated value. Compare the calculated value with the table value for 9 degrees of freedom and 1% level of significance. The table value is 2.262. So mod T calculated is less than T table value. Therefore, we accept H naught at 1% level of significance. So we can write the conclusion as a filling machine may fill 100 grams of baking powder.